But I want to contrast that now and switch gears and talk about some brass tacks, hard challenges that I've seen when you take these technologies and try to convert them into products that can reach real users, right? And roughly, these are the themes, right? One is, which product problems do you go after? Like, what problems do you attack with these technologies? The second theme, roughly, is, OK, once you've decided a product area, how do you design the feedback loops? How do you measure and improve the progress? And then finally, how does it adapt and tailor to each user over time? I want to caveat here, these are directional observations, not a detailed instruction set. So these are just directional observations from the work that I've done and work that I've seen at Google. First problem, or when you look at which problem areas to go after, let's say you have these building blocks, which problem area do you go after? And one of the observations I have is that it's much easier for yourself as a product builder to go after problems that are hard for people and easy for machines. The users are far more tolerant of inaccuracies. My favorite example here is translation. Most people, if you're like me, can speak one language. If you're Trump, maybe barely even that. But so if you have inaccuracies in the system, the alternatives are really bad, like maybe it's sign language. So you're much better off in terms of attacking problems that are really hard for people. Another example here is some problems start out to be easy, right? I mean, in the 90s, I probably had 100 pictures throughout the year. So organizing pictures wasn't a big deal. And now I have thousands of pictures of my kid just from the weekend. And so some problems actually become harder for humans with scale, and those are interesting opportunities. The second angle to look for when you're looking at products to build is look for network effects. That is, does the system get better as more users use it? This is a fun example. It's a simple feature in Google Search where you can look up a place, a restaurant, for example, and we show you the popular times, the busyness of the place over time, over the different times of the week, and also how long do people stay. Now, obviously, this is based on patterns, aggregate and anonymize patterns of foot traffic to the places, and of course gets better as more people use it, right? So look for network effects when you're looking at which problem areas to go after. This one's an interesting one, and let me unpack that. I guess it's related to what Peter said yesterday about the inattention valley, and the idea here is that all these systems are imperfect, newsflash, right? So there will be a precision recall trade-off in almost any system you rely on. But what you want to pay attention to as a practitioner is the cost of getting it wrong. Let me give you an example, right? Let's say you're building a search system, and you returned a slightly less relevant article about Hillary or Trump or the presidential debate. It's annoying. It's not the end of the world. But let's say then you built a local search product where you said, oh yeah, Home Depot is open, you should go to Home Depot. And then you get in the car and you drive over there and it's closed. And you say, what the hell, right? So the cost of doing that, getting that wrong is higher. And then most recently when we were working on the assistant area, if you said, hey, your flight is on time, don't worry, you just have to leave right now, and it takes 45 minutes, and then you go to the airport and you miss the damn flight and can't speak at the conference, then the what the hell is much higher. So the cost of getting it wrong is really dependent on the domain. So when you look at the domain, be very clear about that trade-off. And what we've seen anecdotally from evaluation and user studies is that there's for every what the hell moment, you have to do a lot more to compensate, to have that trust, to regain that trust with the users and say, OK, I can rely on this system. This observation is about the fact that you can and you should measure and optimize metrics that are relevant to the product. But one clear trade-off here is that the trade-off between being predictable and straightforward versus completely black box and predictive. So for example, right, if you're playing a game and your whole goal is to get a winning outcome, you don't really care about it, and you should be optimizing for the winning moves, right? But on the right-hand side, one of the experimental features that our team worked on is saying, hey, wouldn't it be cool if you had the Android home screen launcher predict the next app you're going to use? right? So anytime you open the phone, it would just tell you, oh yeah, this is the next app. It's 4 o'clock in the evening, you tend to use Maps, here's the Maps app for you, one tap away. What we found, though, when we were prototyping and testing is that even if 99% of the time you got that right, users relied on their specific muscle memory to go through certain things. And so when you're looking at a task that they do multiple times a day, it's almost easier, even if it's more efficient, right? If you look at the area under the curve, it's more efficient 99% of the time for our prediction to be used. Users still prefer a deterministic, straightforward way of doing things that they do over and over in a day. So depending, again, on the domain you pick, you want to look at the trade-off of saying, is there a reliable deterministic way versus highly predictive? There's a thin line between magic and flaky.